Okay, in the last class we have seen pipes, no pipes and streams. Streams are for change data capture and pipes are for continuous ingestion of the data. In today's class, let us go through the concept called task, which is used for scheduling the SQL scripts or whatever it is used for scheduling. So inside the database and schema, I'll click on create. Here we have this option task. 1 second. Okay, here we can create the task. It has given the syntax. We just keep the names here. Create task. Task name is scheduled stream. So in the last class we have seen there is a stream table created, and from that stream table we are inserting the data into some other table. Now I want to automate that process. So my stream name is scheduled stream. Sorry, my task name is scheduled stream. So warehouse, we can provide any of these two. I will provide this one, small warehouse. Small warehouse is created by us and the other one is has come by default. I'll provide this. Schedule, we have to provide it in minutes. Either we can provide a cron expression or a time, 10 minutes or 20 minutes like that. I will go with the minutes. I'll remove this. I'll just keep this as 2 minutes. So if you keep long time, you have to wait for the long time. That's why I have kept only 2 minutes. Comments are optional. These are all optional parameters. So if your query use a task timeout in milliseconds. So if you want the query to abort it after running for 2-3 minutes, you can do that. For now, I don't want that. I will keep these options all commented. These are all not mandatory. Here we have to provide the SQL script. Which script you need to automate, which script you want to run it for every 2 minutes. We need to provide that. So I want to automate this stream table. 1 second. Okay, sorry. So here we have to provide the SQL which we want to execute to run for every 2 minutes. So this is our backup table. Let us see in our previous one. I want to insert into order stream backup as select star from order stream. Here I will provide the completely qualified name, I mean database schema, everything. Testdb sysadmin dot schema dot table as select star from Order stream. Here also I'll provide the completely qualified name. First we'll run this if we have any data in this or not. Let me copy this. Okay, this is the same query. So there are no operations happened after our last class. So that's why this table is empty. So I want to automate this process to check every 2 minutes if there are any new entries or not. I will write this SQL query here. Create a task with this. Go to database object and schema. Click on create task. It has given the syntax again. I'll remove this and paste our query. So this is the query which I want to execute every 2 minutes. So I'll create this. Now the task is created. Just like a pipe, here also we need to resume this task. As soon as it is created, it will be in suspended mode. If we want to resume it, we have to alter the task. Now I'll do that. Go to projects. Alter task. Our task name is schedule stream. Schedule stream. Let us see if it is showing here or not. Okay, schedule stream is our task. We have to resume this. Now our task is successfully resumed. So unless and until there are any operations on that orders table, there won't be anything to insert. First, let us check what is there in the backup table. If you look at this table, this is our target table. Let us see how many count are there in this. Count row start from. So here we have 1883 records. So if now we can modify this table and see. Our main table is this order details. Because we have set the stream on this task. Stop me if you have any questions. Let us see what is there in this table. So let's start from order details. So here we'll update something. Okay, I will update the ship date here. Update this table. So as you already know that update works like a delete and insert. So if however number of rows are getting affected, double the number of rows are getting inserted into the stream table. Update table set ship date equal to date of. I want to convert it into a proper date format. To date of ship date. This is in format date, month, and year. Where I'll convert only for few transactions, not all of them. Only for the region central, where region equal to central. First, let us see how many rows are there for the region central. Order details. So with the region central, we have 1160 records. I'll update those many records now. Where is this? Okay. I'll update this. 1160 rows will get updated. So these number of rows get updated. I'll select the data now. See, now it is in proper format. Now we'll check the stream table. Uh, we will check this table, order stream. Select star from. So now it has updated 1160 rows, but this table will have double the number of rows. Orders stream. So we have double the number of 1160 are the actual rows which got updated. This is double because it have uh, half of them as insert and the other half as delete. Why is it empty? Once again, let me run it again. Update statement. Okay, because this is already updated, I'll update to some other region. So 463 rows were updated. Maybe because we are running this select star at the same time, and maybe the task has run at the same time. We'll see. So 926 rows are there. So it has 926 rows. Let us wait for 2 minutes and see the this task. This task is nothing but the orders backup stream. Let us see how many are there. Select star from order stream backup. Let us see what does this table have. So in the last class, we have updated only for the north and uh, south regions. But today we have updated for the central region. Let us see if we have the region central here. This is not region. Yes, central region. So we have 2322 rows related to central. This is delete. We'll write where region equal to central. It is 2322 rows got affected. So here we have two types of operations. Delete. Delete is the existing data. It is deleted. So some rows will be there with insert. Insert rows are what is existing now. See, insert rows have the correct date format, and the deleted rows have whatever is there from the raw file. See, these are the delete which has the raw data. Now we want to see if our stream has executed successfully or not. Sorry, not stream, task. So in order to check that, we can use select star from. One second. Sorry, Andy. Okay, central, sorry, as we have created task, it is executing automatically every 2 minutes, and the data is getting inserted into the order stream backup. So the proof is that here we did not insert anything manually into this table, but we can see the delete and insert. So some of them are delete, half of them are delete, and exactly half of them are insert. We can see the history also. Select star from information schema dot history, task history. Okay, I think it is in Snowflake schema. We can search for the object here. Task. Okay, we can query this table and see. So our we have created this to run it for every 2 minutes, and this has executed 4 times. Let us see. This is the statement which we have given for the task operation. So it is executing on this schema, and the schema ID is this. It is automatically generated. The schema ID and the database ID is automatically generated. So this schedule time, see, it has started at 5:44. First run is 5:42, next 44, 46, and 48. So it is running every 2 minutes. And it is also giving the end time. It started at 5:44, 36 seconds and ended at 44 seconds. Just hardly it has took 10 seconds to insert. And it has given the status as success or failure. So these are all some parameters generated by default. This is a query ID for each transaction. It not transaction. Whenever we run a query ID will be generated. So this is the query ID of that particular query, particular insert operation. That query ID is the ID of this insert operation. And then these are all some run IDs generated by the Snowflake itself. So no need to worry about this. You just have to look at how many times our task got executed. So if we do not stop this execution happens every 2 minutes and it costs a lot in Snowflake. So now we are learning it just for the training purpose. So we don't want to run it in the continuously. In the real time, we can do this continuously. It keeps on happening, but now we don't want this. So I will stop this alter pipe, not pipe, sorry, alter task, our task name. Ideally, we have to stop this pipe as well, because if there are any files coming into the S3 bucket, that will get loaded automatically into the Snowflake. But that AWS account and Snowflake both are owned by me and nobody is using it. So we don't get any files unless and until I load it. That's why I did not stop it. Ideally, if you are doing it and if the files are expected in S3 location, we should stop this pipe as well. Otherwise, it will cost you. So my task name is scheduled task. Scheduled task. Alter task, scheduled task, schedule stream. Our task name is schedule stream. Suspend. So the statement is executed successfully. From now on, it won't run unless and until we refresh it again or the resume it again. See, till I have suspended, it has run for the 7 times. When we have queried, it had run for 4 times. Now it has run for 7 times. So now I have suspended, it will not run again. We'll query after some time and see. So this is how we will schedule the tasks, either based on uh, time or 10 minutes, like 10 minutes, 20 minutes, or 1 hour, like that. We can define in minutes or using the cron expression. So cron expressions, you will find in Google how to provide that. Basically, just the minutes is enough. You can get the cron expressions for each day. Based on the schedule, you can get that. So here is the pattern how we have to define. So if you want to run every minute, we have to provide the expression like this. You can Google it and see based on your requirement and provide it. Instead of minutes, you can provide in that expression format. Here, instead of 2 minutes, you can provide 5 stars if you want to run it every minute. So here it says this the first one will denote the minutes, next star will denote the hour, next one will denote month, and next is which day of the which month. This is day of the month, which day of the month from 1 to 31st dates, and this is month number, and this is the day of the week. So there will be 5 placeholders in a cron expression, and you have to decide based on that. So if you want to run every day at 10 o'clock, so you keep this as star, hour should be 10, and day should be star. Everything should be star. Just 10 o'clock every day is like star 10, and remaining 3 stars. That is how you have to define it. Look at this document and just replace the numbers based on your requirement. So this is about task. Any doubt here?
No, Nick.
Okay. Next, we'll connect with SnowSQL. I'll show you how to connect with SnowSQL. This is like the UI interface, user interface. The Snowflake can be used in 2 ways. One is through the UI and other is through client interface. SnowSQL is the client interface. Through the command line interface, I can say. SnowSQL. So we have to download this SnowSQL. So here it is given for different versions. Now my system is Windows. I'll download for Windows. Just like as Python, we have to download this. Now it is downloaded. So we just have to click next. So where we have to install this, I'll keep this as default. Install. Mm, It is installing. I'll cancel this and restart. Let me check if my computer already has this SnowSQL. If you want to check if it is already there or not, you just go to command prompt and type SnowSQL. So it is not there. Downloads. Next. Okay, this is installed. Now SnowSQL is installed. Oh, sorry, it was interrupted. Okay. Mhm. It is not running here as well. Ready to install. Where is it? We'll delete this. It is open. Ah, here it is. Cancel. I think it is stuck. Okay. Meanwhile, we'll go with the query optimization. You can name your sheets like this query optimization. So here I'll show you whenever you run a table with select star with select only required columns, what is the difference. So now go to this Snowflake sample data. This is given by the Snowflake itself. They have given some sample data to try. In this, I'll take some tables. Just select the database Snowflake sample and schema as this. Warehouse is already selected. Select star from store returns. There is a table called store returns. Let us do limit 10. So this table has some identity columns. I will join the store returns table with the date dimension table, which is this. The joining column will be SR returned date key. So from the date dimension table, let us see what is the common column. So from the, I want to join these two tables. I know that date SK is the common column in between. If you look at the data and do some work around, you will be able to find what is the common column. So that date SK column is equivalent to this one. So I'll join these two tables on. I'll do a left join or inner join. Anything is fine. I'll do inner join. Date dimension table. I will name this as some alias name returns, and this as a date table as D. Inner join on R dot s date return date sk equal to P dot D date sk. Now I'll run this query without any limit. I have just joined. I did not apply any filters. Just I have applied an inner join on this date column. I run this query. So this table, let us see first the size of this table. Store returns is, where is this? Um, Store returns is size is 116, more than 100 GB, close to 120 GB. If you look at the size here, it is 116 GB. The data is so huge. Let us look at the date dimension table here. What is the size of that? Date dimension table size is 7 MB. So this date dimension table will hold only the date columns, like date SK, date ID. These are some ID columns generated to identify. And these are all the, this is date. The minimum date we have is 1900. See, this is the minimum date we have, 1900. Year as the minimum date. Date, month sequence, week sequence, quarter sequence. We have all things related to a date. It is like a calendar. So that is 7 MB and the stores table is a 120 GB. With this data, if we run, it will take a lot of time. Maybe 1 or 2 hours it will take. But let us apply some filters on this. Let us run this first. It will take some time to execute. I will let it run for 1 minute and I will cancel this because it will take around 1.5 to 2 hours. So here it is scanning the bytes. Till now 1.4 GB of data is scanned and these many rows were produced for the output. I'll click this query ID, open it in a new tab. It is still running. I'm going to cancel this. Till now it has read 3.5 GB. I will cancel this and it has produced 69.6 million rows. So instead of select star, I will select only a few set of columns. To select them, let us take select star from this table. With some limit. From this date table, I wanted to take year, which is this one, B year. and, and also quarter. Uh, Let me see which will make some meaning. Okay, I will take only the year column from this table, and from the other table, limit. mm, From this table, I will take this customer ID, SR customer, SK, and store SK. And some amount related columns, I will take store return amount, store return amount, and store return tax. And store return tax. So I want only these columns. And also I'll apply a filter on the year column, and year equal to I want data only for the year 1999, and I'll run this query. It is SR store SK, or this year column is D underscore year. This will also take some time because the data is so huge in the store returns table. This also will take around 5-10 minutes. I'm going to cancel this. Where year equal to, I'll just run this query without any joins. This is not year. That year is in date dimension column. Let me see what is the column name for year in this. So there is no year. We'll filter out on something else. Okay, I will filter with store SK. Store SK is like a store ID number for each store. Just like employee ID, we have the store ID. I will do minimum and maximum of this number. Store SK. Maximum of store SK. So even though we have a limit here, it will apply on the whole data. The aggregates minimum and maximum will apply on the whole data. So the minimum store SK is 1 and the maximum store SK is 1498. Let us see the query plan for this. So we are checking the minimum and maximum on one of the columns. So that's why it has total 70 partitions, 7,000 partitions. So in order to get the minimum or maximum, it has to compare all the data in that. So that's why it has scanned all the partitions. So our query, this is like just like to know the data. This is fine. But whenever we are writing some joins, we need to make sure that the number of partitions scanned and total partitions should not be same. Should not be same in the sense partition scan should be very less compared to the total scans. Then only our query is in an optimistic way. So, for example, if we are searching for an object in our home, if we are searching the whole, we know that it will be found in the kitchen. If we just search in the kitchen, it will take less time. But if we are looking all over the home, it will take more time. So the same concept applies here. If we are searching only 1999 data, it will search only some partitions in the background. Otherwise, if we are searching the whole data, it will do scanning of all the partitions. Our query should be in such a way that the number of partitions scanned should be very less and the time of execution also should be less. Now, I will take a select star from store returns where store sk sr store sk equal to 1. I want the data with store id as 1. Let us see how much count is there. This it has 37 million it seems. This count is like a metadata operation. It won't actually execute on the table. It is like a metadata operation. Again, it has searched all the rows except the header. It has total 70 partitions and it has scanned 7069 partitions. So instead of that, I will do select star. Better to apply some other filters as well. Here also I'll apply some limit. So whenever you are free, try with these type of queries. If I want to show now, it will take a lot of time, 2 hours itself to run the query. Whenever you are free, you can try that. Along with store SK, I'll apply something else as well. What else can be applied? This is all a single value. I'll apply filter on this. And SR HDemo SK equal to 5762. Let us do the count on this. Yeah, just doing the count. It is 513 rows. Look at the query execution plan now. Still, it has scanned all the partitions. I will do select star. It should return only 5 and 3 rows now. Look at the query execution plan. See, the table size is, we have seen that store SK table size is 112 GB. This is 112 GB. Sorry, 116.2 GB. If you look at the query execution plan, it has scanned 21, almost close to 22 GB it has scanned. So it is little better. Still, the number of partitions scanned are 7069 and the total partitions are 7070. So it is not efficient because we have did select star. Instead of select star, I will take only few columns SR return. In real time, every time we don't need all the columns from all the tables. We just need 3 or 4 columns from each of the tables. SR item SK and SR customer SK. The time taken is 29 seconds. 29 seconds when we did select star. But when we did only select required number of columns, only 3 columns, the query time has come down to 6.9 seconds. Now look at the query execution plan. So previously it has scanned 21 GB. Out of 116.2 GB, it has scanned 21 GB when we did select star. But if we have selected only the required number of columns, then it has come down to 8 GB, or we can say 9 GB. So this partition scan will get reduced whenever we are doing with the joins. This Whenever we are running these join queries, we can see a reduce in the partition scan. If we do it on a single table, we will not be able to get it. So, but the performance optimization, it all depends in all the parameters. The most important thing is bytes scan and also the partition scan. So out of 116 GB, how much data is being scanned for our for our requirement? So it should be as less as possible, and also the partition should be as less as possible. You have to keep in mind about these 2 parameters and also the execution time, and then modify your query accordingly. I will paste this query in the chat window. You can try whenever you find some time. You will find a difference in the number of partitions scanned. So query optimization, basically in Snowflake is a columnar data warehouse. I will say what techniques we need to follow. So as you say, it is a columnar data warehouse. Instead of select star, selecting only the columns required will result in optimization. So we should not do select star. Instead, specify only the required columns. Because this is a columnar data warehouse, retrieving columns is faster than retrieving rows. Select star will do the retrieve rows. That is why it is taking some time. Do only select required columns from this table. So while joining also, this date dimension table is short. It is only 7 MB. That is fine now. But even the joining table is so big, like 100 GB. Then instead of that 100 GB, we can write a subquery here. Select only 10 or 20, select only 5, 10 columns with some filters on the date column and some ID columns. We can apply that. But if we do it directly like a date dimension without anything, it will scan all the data. Instead of that, write a subquery here. This date dimension table is small table now. It won't make any difference. Now from this table, we need only the year column and SK column. So we need only these 2 columns from this table for the year, for the year 1999, and name this as D. Previously, we have taken only this date table as D. Now we can take this whole thing as D so that while joining, the number of rows get reduced. Let us say we have 100 years of the data in the date dimension table, and now we are taking only 1 year. That is how the data gets reduced in the join. So we have to perform optimizations like this. Whenever you are free, you try this with the join. Then you will be able to find the partitions reduced. Now I have shown only the amount of data is reduced in this table scan. So whenever you run a query while joining two tables, when we are running with a single query, I mean single table, it won't make any difference. But when we are joining with the two tables, more than one table, then these partitions will come into effect based on your efficiency in joining and efficiency in reducing the amount of data scanned. So you will play around with this query, apply some filters, make subqueries instead of referring the whole table. Then you will be able to see the number of partitions scanned will also get reduced. So any questions here?
Only complete.
Okay. In Snowflake, we do not go for indexing. In usually in SQL, any type of SQL, we do indexing, but Snowflake, we don't have to do that indexing. It will be done automatically on the background. If the data size is less than 1 TB, the indexing, everything happens. The sorting, partitioning, everything happens automatically on the background in an optimized way. We don't need to interfere it. That is how we optimize the data. Tomorrow I'll show you the SnowSQL. It looks like this is struck. I will install this NoSQL and I'll show you how to connect with the command line interface. Okay, if you have no questions, we can stop for today.